Question number 1 states that if the vessel in the sample problem at the top of the page accelerates for 1 minute, what will its speed be after that minute? Now in the original problem, it was starting from rest, 0 meters per second as its initial velocity. We're looking for what the final velocity will be after a time of 1 minute or 60 seconds. The acceleration that it was given in the problem was 1.8 meters per second squared. So make sure you write this down. Question number 1, time is equal to 1 minute or 60 seconds. Acceleration is equal to 1.8 meters per second squared. Initial velocity is equal to 0 meters per second or rest. And we're looking for our final velocity. The equation we were using, acceleration is equal to delta V over t, or our change in velocity over the time, final velocity minus initial velocity. Of course, can be rewritten by using algebra or simply by using the equation that we had from Tuesday, or if you look in the book, the equation. Our final velocity is equal to our initial velocity plus the acceleration times the time. Now don't forget, if our initial velocity is 0, then obviously our final velocity is just the acceleration times the time. This should help you get the first part of our answer, which is in meters per second. Since we converted 60 seconds, we have meters per second squared, and we have 0 meters per second here. Just by plugging in our 1.8 as acceleration and 60 as seconds, we should get our final velocity, which you should be working on right now. So let's see, 60 times 1.8 equals, anyone? Okay, good. Now the second part of it is we need to take this number, which was given to us in meters per second, and convert it to kilometers per hour. Since it's already in meters per second and now we're converting it to kilometers per hour, what we're going to do is we're going to use the conversion factor of 3,600 seconds in 1 hour times our 1 kilometer is equal to 1,000 meters conversion factors to give us a final answer. Keep it to yourself when you get it in there. Problem number 2 states that in 1935, a French destroyer, La Terrible, attained one of the fastest speeds for any standard warship. Suppose it took 2 minutes and a constant acceleration of 0.19 meters per second squared for this ship to reach its top speed after starting from rest. Calculate the ship's final speed. Once again, we're looking for our final speed or final velocity. We've been given an acceleration of 0.19 meters per second squared, 0.19 meters per second squared. And our time is 2 minutes, which we can convert right off the bat. 60 plus 60 is 120 seconds. Our initial speed, once again, 0 meters per second. So, going through all this, acceleration is delta V over t. Final velocity minus the initial velocity. Final velocity is equal to initial velocity plus our acceleration times our time. Once again, the initial velocity is 0. So our final velocity is simply our acceleration, 0.19 meters per second squared, times our time, 120 seconds. Anyone? Oh, keep it to yourself. Write it down. Make sure you have all of this written down. All these steps are important. Number 3 says, in 1934, the wind speed of the Mount Washington in New Hampshire reached a record high. Suppose a very sturdy glider is launched in the wind so that in 45 seconds the glider reaches the speed of the wind. If the glider undergoes a constant acceleration of 2.29 meters per second squared, what is the wind speed? Assume that the glider is initially at rest. All right, information we have here. Once again, the initial velocity is 0 meters per second. The glider is launched so that in 45 seconds it reaches its maximum speed. So our time is 45 seconds. Our acceleration of the wind, which, since the kite is being carried by the wind, and assuming that it is moving fluidly with the wind, it is accelerating at 2.29 meters per second squared. 2.29 meters per second squared. Once again, our initial velocity is 0. Through all our algebra, our final velocity is equal to our acceleration, 2.29 meters per second squared, times our time. Put it in the calculator, work it out. In 1992, Maurizio Damiano of Italy walked 29,752 meters in 2 hours. Calculate Damiano's average speed in meters per second. All right, we have this in meters, but we're looking at hours instead of seconds. So this problem is a two-part problem. The first thing we have, I'll erase all this stuff, is we're given a time of 2 hours. And remember that in every hour there's 3,600 seconds. So since you got 2 hours, it's 3,600 times 2. Or 7,200 seconds. You're writing that down, I hope. We're given a distance, x, is equal to 29,752 meters. So you wrote that down. The average velocity is equal to our distance traveled and the amount of time it's traveled in. So we have 29,752 meters divided by 7,200 seconds. And this will give us an answer in meters per second. Alright, so you work that one out. Now, the second part of this question.
So you find the answer for part A, and now you notice that there's a part B of this problem. So 4B says, suppose Maurizio Damiano slows down to 3 meters per second at the midpoint in his journey, but then picks up the pace and accelerates to a speed calculated in part A. Well, remember in part A we had our equation boiled down to our distance x, which was 29,752 meters, and that was over the time of 2 hours, which is 3,600 seconds times 2, which is 7,200 seconds. And if you do the math on that and you found the answer for part A, then you would know that the answer was 4.12 meters per second. So in part A, the answer was 4.13. meters per second. So, oh, yes, Sean?
I have my lab completed for you.
Oh, you've completed your lab?
Yes.
All right, and you put your name on it?
Yeah.
This is the motion lab we did. What did we use? We used Wally, right? And then a bowling ball?
And a bowling ball.
That was
Very
nice.
small bowling ball.
That's kind of exciting, huh? And you got the graphs. They look very nice. All right, very good. Thank you very much. I'll put this right here on the pile of labs that were completed on time.
Okay.
All right, so let's get back to this. So what we have here for part B, all right, our problem tells us that we have a final velocity. It slows down, which is VF, is 3 meters per second, 3.00 meters per second. And it said we got our initial velocity, VI, from our answer that was in this equation right here, and that was 4.13 meters per second. And all this occurs in 30 seconds. So the time that it takes is equal to 30.0 seconds. All right, so now we're looking, we have our equations that were given to us at the beginning of this in the sample problem, and we see right here, we're looking for acceleration, find the magnitude of the average acceleration during this time interval of 30 seconds. Well, we have a final velocity of 3 meters per second minus an initial velocity of 4.13 meters per second divided by a time of 30 seconds. So when you put that in there, you will notice that 3 is a smaller number than 4, so your answer will be negative. And when negative acceleration means that it is a deceleration taking place, or it's slowing down over 30 seconds. So all you have to do to solve this part B is take your final velocity, 3 meters per second, subtract your initial velocity, 4.13 meters per second, and then divide that answer by your time, 30 seconds, and you should get an answer that's somewhere in the negatives. All right? Go right to work. All right, so question number 5 states the South African frogs are capable of jumping as far as 10 meters in one hop. Suppose one of these frogs makes exactly 15 of these hops in a time interval of 60 seconds. What is the frog's average velocity? All right, so what we have here is we have acceleration and we have a change in velocity over time. But this problem goes back to what we've already done in our previous section, problems 2A, where we studied velocity, and we know that in order to find our average velocity, we need a change in position, which we call d, it could be x, over our time period that it takes place. So our change in position, right, so we have our position x, also known as delta d, all right, is equal to 10 meters for one hop, but in 15 hops, we multiply that, 15.0 hops, we multiply that, and we have 150 meters total of distance, and this will take place in a time interval of 60 seconds. All right? So it tells us that our time interval is 60 seconds, and that we have 10 meters per hop, and if a frog makes 15 hops, 10 meters each, that's 150 meters that this frog will change position on the horizontal axis during a time interval of 60 seconds. So in order to solve this problem, all we need to do is to take our 150 meters and place that as our change in position and divide that by 60. All right, so our velocity is equal to 100, little arrow on there. Our velocity is 150 meters divided by 60 seconds. So you should be able to do this with a calculator at home and figure out what it is the answer is, and then go ahead and write that right on your sheet. All right, so we see here part B for 5. If the frog lands with a velocity equal to its average velocity and comes to a full stop 0.25 seconds later, what is the frog's average acceleration? All right, so we're looking for acceleration, and we have our equation that's given to us for acceleration in this section, that our final velocity minus our initial velocity divided by the time interval it takes place. So we're going to need our answer from part A. So our average velocity that was the frog was hopping at for 150 meters in 60 seconds. Alex, what'd you get for that?
2.5 meter per second.
All right, you got 2.5 meters per second. So our average velocity is 2.5 meters per second. So it's going to come to a stop. So our final velocity is going to be 0 meters per second because the frog comes to a stop. Our initial velocity before it comes to it is this average, 2.5 meters per second. And the time interval is 0.25 seconds later. So for part B, we're going to use the same equation like we did before. All right, so we have part B, and we have our acceleration is what we're looking for. And we have our final velocity is 0 meters per second minus our initial velocity, which is 2.5 meters per second. And that's divided by our time interval of 0.25 seconds. Well, that's the bell. So you should be able to use your calculator and understand that, once again, this is decelerating, so it's a negative acceleration. And we have 2.5 meters per second divided by 0.25 seconds. And you get your answer. And then you're done with the homework for tonight. So have a great night. And hopefully, if you have any more questions, you can come see me during advisement period, which begins right now.